Hello everyone, this is Balu. Welcome to my channel Civil Cave. In this video, I am going to continue the CODAL provisions regarding the design of stiffeners. In the previous video, I already discussed about some of the CODAL provisions regarding the design of stiffeners, and this is the second part of the video, that is nothing but the design of stiffeners CODAL provisions. And also, if you like my content, please like the video and also subscribe my channel and also share with your friends who are working in the civil engineering industry or who are pursuing the degree in the civil engineering. Okay, let's get into the video. Here, coming to the CODAL provision, that is load carrying stiffeners. And corresponding load carrying stiffeners, this is regarding the web check. Load carrying stiffeners means that whenever the web is not having the capacity to take the load coming onto it, the stiffeners are going to be provided at the locations wherever it is necessary. At those locations, the certain part of the load is taken by the stiffener. So that's why they are called as load carrying stiffeners. Now coming to the load carrying web stiffeners should be provided where compressive forces applied through a flange by loads or reactions exceed the buckling strength FCDW of the unstiffened web calculated using the following. So whenever the concentrated load is applied on the plate girder, if at that location, if the web is not sufficient to take the load, then at that locations it is necessary to provide the stiffener, that is nothing but the load carrying stiffener. So to calculate the capacity of that web, here it is given that the effective length of the web for evaluating the slenderness ratio, that is taken as the area of cross section as B1 plus N1 into thickness of the web. So whatever the buckling check, this is same as whatever the previous buckling checks we have done, that is we have to calculate the FCD, design compressive stress, and into the cross sectional area of the whatever the section we are going to consider, and based on that you are going to get the buckling capacity of that cross section. So similarly here also you are going to calculate the buckling capacity of that web, but what is the cross section you are going to consider is, it is given that is B1 plus N1 into thickness of the web. Now what is this B1 is, that is the width of stiff bearing on the flange. So whenever the concentrated load, that is P, is acting on the, that is compression flange, this is one, and this is the tension flange. Whenever this concentrated load is acting on this compression flange, the length on which the load is concentrated, here I am taking that as B1 is equal to 0 because I am considering this as a concentrated load at a point. For example, if the load is acting on as patch, so certain patch load, it is acting as a patch load and it is taking as a certain length, for example this as B1. So for example this is a top flange, and if the load is acting on a certain width, considering it as B1, at that time you have to consider this width as B1. So here the load is acting as a concentrated load, so that's why I consider this B1 as 0. Now coming to the N1, this is the dispersion of the load through the web at 45 degrees to the level of half the depth of the cross section. So up to the half the depth of the cross section, I have already drawn this axis. So this load is going to disperse at 45 degrees angle. So at that mid depth of the plate girder, you are going to get a certain width, that is N1. So this is nothing but the N1. So if it is acting as a patch, then it is going to distribute in 45 degrees, and at the certain depth, that is mid depth of the plate girder, this length is nothing but B1 plus N1. So at that time you are going to consider this as a B1 plus N1 in the cross section. Here this case is B1 is 0, that's why I am considering this B1 as 0, and coming to the N1 I have shown clearly. So based on this area you are going to get the FCD and also the cross sectional area, so that you can get the buckling strength of the cross section. So you can get the buckling capacity of the web. So if the whatever the load which is coming onto the plate girder is greater than the buckling capacity of the web, at that time you are going to provide the load carrying stiffener. Next, coming to the other CODAL provision, that is design of load carrying stiffeners, buckling check. The external load or reaction effects on a stiffener should not exceed the buckling resistance of the stiffener as given in 8.7.1.5. This clause I already explained in the initial only. This clause I already explained in the initial part of the video only. So please go through it. This codal provision is regarding that whatever the external load or reaction is acting on the stiffener, it should have the buckling resistance to resist that particular reaction. So this is regarding that. And next, coming to the other thing, where the stiffener also acts as an intermediate stiffener, it should be checked for the effect of combined loads in accordance with 8.7.25. This is also I already explained this 8.7.25 codal provision. So please go through it. And also coming to the next thing, that is bearing check. Load carrying web stiffeners should also be of sufficient size that the bearing strength of the stiffener FPSD given below is not less than the load transferred Fx. So whenever the load is concentrically acting on that whatever the plate girder, so at that location this plate girder should have the capacity to bear that high concentrated loads. So whenever the stiffener is below that concentrated load, this bearing contact area should be enough so that it should resist the reaction or load coming onto the stiffener. So what they have given is this bearing strength is nothing but AQ into FIQ by 0.8 gamma MO should be greater than or equal to Fx. Fx is nothing but the whatever the concentrical load which is acting on the plate girder. For external load or reaction here it is given. It's coming to the AQ. This is the area of the stiffener in contact with the flange. So here the flange is there and also you can see the stiffener. So if you see in the top view, for example, this is the web and this is the stiffener and this is the contact area of the stiffener with the flange. So whatever this contact area you have to consider is in case of AQ. So now coming to the FIQ, this is the yield stress of the stiffener. It is depends on the grade of the steel. Next, coming to the other codal provision, this is regarding the bearing stiffeners. Bearing stiffeners should be provided for webs where forces applied through a flange by loads or reactions exceeding the local capacity of the web at its connection onto the flange Fw given by. So whenever the external load is acting on the plate girder, when it is not having the sufficient capacity to bear such high concentrated loads, at those locations we have to provide the bearing stiffeners. So whatever the bearing capacity of the web is calculated using this formula, that is Fw is nothing but B1 plus N2 into thickness of web into FIW by gamma MO. What is this B1? Is nothing but the stiff bearing length. So here I already explained about this stiff bearing length. Whenever the load is acting concentrically at those locations, B1 is nothing but 0. If it is acting as a patch load at those locations, it is certain width should be there. And next, coming to the N2, here the length obtained by dispersion through a flange to the web junction at a slope of 1:2.5 to the plane of the flange. So here the load which is acting, it is spreading at a slope of 1:2.5. So whenever it is dispersing at a 2.5 slope, at the connection or at the junction of flange and also the web, you have to consider this N2 length. So this is a junction part of the flange and also web. So I am mentioning here as a N2. If it is acting as a patch load, then there should be a length for the B1 and also at those locations B1 plus N2 you have to consider. And the basic difference which I have explained before and now is, here we are considering this length at the junction of flange and web. But in the previous case, we considered the length at mid depth of the plate girder. So remember this difference. This is also very, very important. And also thickness of web is nothing but thickness TW is given. And FIW is nothing but the yield stress of the web. These are some of the codal provisions regarding the design of stiffeners. If you like my content, please subscribe my channel and also share with your friends. And also, it is very, very important to learn regarding the design of plate girder if you are especially in the steel domain. Okay, thank you for watching. Thank you.